Hi everyone, this is the first video for section 8.2 on adding and subtracting integers. So we are going to start with talking about models. And so the discussion on models is on page 304 of the book. And we're going to start with models just because I know that you all know how to add and subtract integers. So we're just going to see kind of the motivation of why we can do the things that we do. So the first thing we're going to do is we're going to use this sign model. So for a sign model, we draw signs, either a positive sign or a negative sign, to represent each value. And what we're going to do is we're going to say that one positive and one negative together is a zero pair, and those cancel out. So this really just represents the fact that we know that -1 plus 1 is 0, right? If we have a negative and a positive, we know that they're going to cancel. And if you think of this on a number line, if you go to the right to add 1 and then to the left to subtract it away, you get back to where you started. And so we can do this to kind of see what's going on when we add and subtract integers. So in the first example, we are modeling the addition problem -3 plus 4. So what we do is we draw the signs to represent each value. So remember any addition model that we've had? For example, when we used base blocks, we drew the base block representation of both of the numbers, combined them, and then regrouped and then saw what our final value was. So in this case, we're going to have a -3, and then we're going to have a +4. So 3 negatives and 4 positives. So the first thing we do is we draw the signs for each number. So we draw the signs, and then what we're going to do is we're going to do a regrouping, is where we're going to find 0 pairs. Because we know that each time we have a positive and a negative, they can cancel out. So we have 1 0 pair, 2 0 pairs, and then 3 0 pairs here. Okay, and so once we've done our regrouping step, our finding our 0 pairs, we are going to then determine the value of the remaining signs, right? So after we cancel out our 0 pairs, we're going to find what's remaining, and that is this plus right here. So we have 1 positive left. So that's going to tell us that -3 plus 4 is +1. Okay, and so when we do this, we all know that whenever we have this commutative property of addition, so we all know that this problem is really the same thing as 4 plus -3. And we all know that this is just the same thing as 4 minus 3. But that may not come as naturally to students when they're learning this for the first time. So this kind of helps motivate that whenever you're trying to add a positive and a negative number, what you're really doing is you're finding the difference between them, because you're seeing what matches up and then how much bigger or smaller one number is than the other. And that's really just finding the difference between the numbers. And so this is essentially, this model helps motivate why we can switch negative signs to subtraction signs. Okay, so the next one is saying to model the subtraction problem 4 minus -3. So anytime we've done subtraction models in the past, we have typically only drawn the model for the first number, and then we take away whatever we're subtracting. So we're going to go ahead and draw a positive 4. So just like every subtraction model we've done so far, we're going to draw the signs for the first value, which is the value being subtracted from, it's the value you take away from. So we draw the signs for the first value. Okay, so if we have a positive 4 and we are trying to take away negative 3, so we don't have negative 3 here to take away, right? We don't have 3 negatives that we can take away. So what we can do is we can add 0 pairs. Until we can actually subtract like we want to. So we add 0 pairs until we have the signs we need to remove. So we are trying to subtract 3 negatives from this positive 4. So we add in 3 0 pairs until we have 3 negatives that we can remove. So when we remove these 3 negatives, we take the negatives, right? We remove them. And then, so after we have enough to remove, we remove the signs that we're trying to subtract. And then always the last step, we find remaining value, right? We see what we have left after, in the case of addition, regrouping, and in the case of subtraction, taking things away. So in this case, we just have 7 positives left. So that tells us that 4 minus negative 3 is positive 7. Okay, so if you're doing this on an exam, I know that you know that 4 minus negative 3 is 7. And so I have this note up here that says, don't change this. So don't change it to 4 plus 3, because I know that you can do this addition problem. But what I'm really asking, if I ask you to model something, is for you to use the model. Because that's what you're going to have to do if you're ever teaching this to someone. Then you're going to have to use this model to teach it to someone for the first time. Okay, so I just have one little note here that's saying that the parentheses and 4 minus negative 3 aren't necessary. We don't have to have these here. They're only necessary when you have to do one operation before another, remember, in our order of operations. But they're not necessary. They just help distinguish between the minus symbol and the negative symbol. Remember that that minus symbol is an action, and this negative symbol just describes the number. So you can use them if you like or if you don't. A lot of textbooks and worksheets and things like that do put a parentheses around numbers with a negative sign just for clarity. But yeah, you don't have to use them if you don't want to. There's nothing, it's not more correct to do either way. It just helps with ease of reading. Okay, so this is the end of the first page, and this is all we're going to talk about for the sign model using the integer counters. If you haven't seen the word integer counters, go read page 304 of the book, like you should have done already. And that's where it introduces this sign model. These are called integer counters. So next time, we're going to talk about modeling on a number line.